All right, on this video, we're going to take a look back at all the conic sections. So we're going to look at how to identify conic sections. Remember, conic sections are those, all of the ones we've been learning: circle, ellipse, hyperbola, parabola. And this has to do with the shape of a cone. That's why we call it conic. And it's kind of like cutting sections out of a cone in a way. So a hyperbola actually comes from cutting, if you have like two cones stacked almost like an hourglass and you're cutting vertically through it. Well, if you think about that, you'd only, cut small pieces of it because there'd be a section missing in the middle where it's coming together as, kind of a sharp point, if you think of that hourglass where the sand is going through. So to identify the conic section from an equation, the equation needs to be in standard form or the standard format. We need to be able to identify it in this way. So here are a few things to notice before starting to work on your equations. This will help you narrow down your options, okay? It's not going to completely answer the question for you, but it's going to help narrow it down. So if x squared and y squared are both present, then you're either having a circle, an ellipse, or a hyperbola. So that doesn't narrow it down too much, but it's not a parabola. A parabola only has either one or the other. So if only x squared or y squared is present, meaning that one is not squared, you only have one or the other squared, then it is a parabola. So you know right away what it is. If the coefficients of x squared and y squared are the same sign, then it is circle or ellipse, because same sign, meaning they're both positive, they're going to be coming together, right? They're creating a solid or contained shape. If the coefficients of x squared and y squared are different signs, one's positive, one's negative, then you have a hyperbola, because that's when the two shapes are moving away from each other. Okay, so now put the equation. That's a really funny sentence. The equation needs to be put into standard format to determine the conic section, which conic section it represents, and to find either the center or the vertex, because Alex requires this as part of the answer. Once you click on the drop down and say it's a circle, it's going to say, okay, what's the center? So it's not good enough to just know what kind of conic section it is, but also that what the center or vertex is, which means that you need to have it in standard format so that you can see it. So let's go ahead and practice this. So I have 4 equations here. And we're going to go through and we're going to do one at a time. I think we're going to do 2 on this page and then kind of separate them out because some of them take a little bit more room. So if we take a look at this first one here, our steps are first group the x's, then group the y's, which you're going to kind of do at the same time, and bring the constants over to the right side. Since they all equal 0, in this case I can just say bring it over to the right side. It kind of depends on how the equation is set up, but these are all set up the same. It looked very similar for every single one that I looked at. And then you're going to factor and complete the square or squares so that you can set it up into standard form. Okay, so for this first one, it only contains a y term instead of a y squared term. So I already know it's a parabola. I can immediately click the drop down and say it's a parabola, but it's going to ask me what's my vertex. So let's put it into standard form so that we can find the vertex. So I'm going to add 19 to both sides. And then if you notice, I've also grouped the x's. And I put parentheses around the 1y here just so that I've kind of grouped it. But there's anything else to group with it. So I want to factor out anything that I can. So remember, that was this step, factor and then complete the square. So I'm dividing everything by 4. So negative 4x squared divided by negative 4 is just x squared. Negative 16x divided by negative 4 is positive 4x. And then I left a space here so that I can complete the square, because that's what I need to do in order to make it look like the standard equation. I need it to be squared, a binomial squared. So on this side, if you notice, I have the 19 plus negative 4 times whatever I'm going to add in this space. And I have the negative 4 because I factored it out here. So even though I'm going to add a smaller number on this side, I have to take into account that I factored out the 4. So that's why I already placed it on this side, and I'm going to multiply it by whatever number I add in here. So I'm doing the same thing to both sides. I'm not really changing the equation when I complete the square. I'm just kind of increasing it by that amount. All right, so to complete the square, I take the middle term, I divide by 2, so I get 2, and then I square that, so 2 squared, and I come right back to 4. So I'm going to add 4 to both sides here. Okay, so now I can factor this. X squared plus 4x plus 4. That factors down immediately into x plus 2 squared. Okay, that's why we completed the square, because it factors very, very quickly. And I leave that negative 4 in the front. The negative y is still here. And on this side, you can see it went down to 3 because I have 19 minus 16 when I do negative 4 times 4. So 19 minus 16 is 3. All right, so now for it to be a parabola, I want it to equal y. So I'm going to take this negative 4 times x plus 2 squared, and I'm going to add it to the other side. Okay, so I'm going to add it to the right side so you can see that now it's on the right side and it's positive. And we have the plus 3 on there still because that was already there. I don't want negative y though, so I do need to fix the y so you can see now it's positive. I've just moved it over to the other side and it's flipped it. It's negative 4 and it's negative 3. So now I have it in standard form. So now I can grab my h and my k. So I have negative 2 because the original form is x minus h. Okay, so it's negative 2 and then the k is correct. So it's negative 3 here because it's actually plus k on here. So since that turned into a minus, I know that it was a minus 3. All right, let's take a look at the next one here. So this one has an x and a y squared. So I know that it's either going to be a circle or an ellipse. And I specifically know it's going to be one of those two because it has the same sign. So I know it's not going to be a hyperbola. Even though they're both negative right now, that will actually correct itself once we get it at a standard form. I just know right now they're both the same sign, so it will either be a circle or an ellipse. So let's go ahead and move this 18 over to the other side. Sorry, that should be 19. I did it correctly down here, so I'll correct it after the video here. That should say 18, not 19. Silly me. And you also notice I grouped the x's, I grouped the y's. So now I'm going to factor. I can factor a negative 3 out of both of these, and I can factor a negative 3 out of both of these. So I'm going to go ahead and do that, and it definitely gets a little longer here, so you can see the negative 3's in front. So both of these have been divided, and I left a space for completing my square. And then I divided by negative 3 out of both of these, and it's in front, and I left a spot. I also added it to the end here, because I have my 18 plus, I have negative 3 times whatever I put in this first one, and negative 3 times whatever I put in the second one. Okay, so now I'm going to complete the square twice. So I'm going to take 2, and I'm going to divide by 2, and that gives me 1, and then I'm going to square it. Well, 1 squared is 1. So you can see I've added that to both pieces here. And now I'm going to do the same thing with 6. 6 divided by 2 is 3, and 3 squared is 9. So I've added that to both pieces. So immediately I can factor both of these trinomials. So this is going to be x minus 1 squared, because it's a minus here. Or sorry, x minus 1 squared on the outside. And then y plus 3, since it's all plus, it's going to be 3. So when I immediately take the square root of these, or I factor them, I'm taking the square root of the first and the square root of the last. And then I do have to take into account, is it a negative and positive, or is it a positive and positive? It's never going to be a positive negative, because that won't work if it was a square. All right, it's going to be either negative or positive, which means I have 2 negative 1s that I'm squaring, which does happen on this one, x minus 1 squared, or I have 2 positives. So it was a 3 times 3. Uh-oh, I left another square there. That square should not be there. Ignore that square. That was just an oops when I was typing. And then on this side, I have 18 minus 3 minus 27, so I end up with negative 12. All right, so one thing you do want to remember is that none of them are going to have coefficients like this, the negative 3's. So we need to divide both sides by that negative 3 because I need to get rid of that. So that's going to happen no matter what. If it's in a circle, an ellipse, or hyperbola, you're not going to have coefficients like that. You would have an a and a b on the bottom possibly, but you're not going to have coefficients out front. So when I divide by negative 3, the negative 3's on this side cancel. Negative 12 becomes positive 4. So this is the format for a circle. And again, that darn exponent should not be there. So I will fix that in just a moment. So this is h and this is k, and since we know it's a circle, they should be added, or they're being subtracted. So if they're the sign is not changed, it's still subtraction, then it is the number that you see, a 1. But if I see it change to a positive, that means it was a double negative. It was a minus negative. Okay, so let's go ahead and look at the third one here. So for this one, I can see x squared and y squared again, but if we notice that they're different signs, so I know right away it's going to be a hyperbola. I still have a center I have to go find, but I know kind of what equation I'm aiming for here. So again, I'm going to take that constant, I'm going to move it to the right side, and I'm going to group my x and my y's. I'm going to factor out anything that I can. So there's nothing I can factor out of my x's, but I can factor a negative 16 out of the y's here. So I still have to complete the square on this one. So if you notice I left the space for it, I have negative 16 divided away from each one of these because it was a common factor. And I left a space for it. So I have my negative 1 plus whatever I add into this trinomial, and the negative 16 times whatever I add into this trinomial. So same process for each one of these. I know it's a little bit more because we're completing the square a few times, but it's same process. So I have my 2. I'm going to do 2 divided by 1 equals 1, and 1 squared is 1, so I'm going to add 1 to both of these pieces, and that got scooched over a little bit. And I'm going to do the same thing on this one because it's also 2. So it would be a 1 and a 1 again. Okay, so I'm going to factor this one very quickly. So it's x plus 1 squared, and this is going to be y minus 1 squared because there's a minus here. So, and on this side, you can, kind of picture it. So it's negative 1 plus 1 minus 16. So negative 1 plus 1 cancels, so I have just negative 16 come up over there, and I factored my two pieces. So I have my binomials. I'm not going to have that negative 16. Remember, there's no coefficients in front. So hyperbolas equal 0, so they equal 1. I don't know why I put 0. So divide everything by negative 16. And I also don't want this coefficient. So I'm going to divide by 16. So you have it over here. So I have x plus 1 squared over negative 16. So because there was nothing here to cancel it, it was over negative 16. The negative 16 cancels from the y term, and the negative 16 divided by negative 16 gave me 1, which is what that should be. So I do want to fix the order here because this negative, remember whenever we have the standard format, it's always, the negative 1 is always second. So this tells me that it's going to be a vertical hyperbola, or it's going to have a vertical transverse axis. And I have my k and my h. So now I can put this in. So h is negative 1, k is positive 1, and again, these should be negatives in here. So if you see a positive, it was that double negative. So don't forget about that part. All right, we have one more here. Oh, goodness, you get to see part of it already. All right, so we're going to take a look at this last one. We're going to do the same thing. So I have x squared, I have y squared. They're both positive. So that tells me positive or negative, they're the same sign, so it's either a circle or ellipse. Okay, because I already did a circle, it's a pretty good bet. It's an ellipse just because, we're practicing all of these, but I wouldn't guarantee that on Alex. Sometimes they could be exactly the same. You could have two that were ellipses, you just never know. So I'm going to move that negative 4 to the right side, and I'm going to group my x and my y's. All right, and now you can see I've prepared for completing the square in this one, even though there's nothing to factor. I could factor a 9 out of the second one. So the 9's out in front and it's factored away, but I have to leave my space for my completing the square, and then I left my spaces appropriately on the right side. All right, so let's complete the square in this one. So 4, half of 4 is 2, 2 squared is 4, so we have 4 and 4. And then we have our 2 again, so 2 divided by 1 is 1, 1 squared is 1, so I have 1 and 1. All right, so we're going to write it in factored form. On the bottom here, so I have x minus 2 squared for this first one because it's minus in the middle, so it's a minus, and then these are all plus, so it's y plus 1 squared. And again, they equal 9. They do not have coefficients at all, right? So we're going to divide by 9 on both sides. There it is over here, sorry. going a little too quick. I was waiting for it to pop up there. So if I divide by 9, there's nothing here to cancel it away, just like that last one. So I have 9 on the bottom. The 9 does cancel from the y, and then the 9 also cancels on the right side because 9 divided by 9 is 1. So remember, hyperbola or circle, they're going to equal 1. So, hyperbola or ellipse are going to equal 1. Circle can equal something larger than 1 because it's going to be it's r squared is what it equals. Okay. So now I have my h and I have my k, which you kind of already saw pop up there. So it's 2 and negative 1. Again, it's positive because we have that double negative. All right, so this is how you identify the conic section from an equation. I hope this helped, and I will see you in the next video.